The last theorem for section 8.5 is what we call a triangle angle bisector. Now, it sounds a little confusing, but it's really not that bad, so let's just take a look at it. So here I got a triangle, any triangle, very flexible, okay? What I want to do is I want to bisect one of the angles. Now, if you'll remember how to bisect the angles, we'll select the points labeling the angle in the correct order, and then I'll construct the angle bisector, okay? So what you'll see now is no matter how I manipulate this, okay, this angle down here, okay, at A has been bisected, okay? Now, as you can see, the ray bisecting an angle of a triangle divides the opposite side. So the ray out of A is dividing segment BC. So I want to find that point of intersection there, okay? So find that point of intersection, I'll label that D, okay? Now it's dividing it in such a way as it's two parts, right? Okay, so here we go. Again, that could be dividing it, who knows how, okay? But all we're going to say is this, okay, let's measure BD, okay? Let's measure BD, and let's measure DC. Okay, so now let me take the ratio of these two, okay? The ratio of these two, number calculate, okay? So that divided by the DC segment, okay, is going to be some ratio, okay? Because that ratio is subject to change as the triangle changes. But what is going to remain, what that ratio is going to be equal to, okay, is the ratio of the remaining two sides. So BD is going to be on the same side as AB, and DC is going to be on the same side as AC. So what I want to do is I want to measure AB, okay? I want to measure AB, distance AB, we'll put that up here, and I want to measure AC. Measure AC, okay? Measure the distance AC. And now I want to take their ratio, okay? So let's calculate, number calculate. The ratio of AB to, okay, AC. Okay, and you can see that's the same value, regardless of how I manipulate this, okay? Those two are the same. So I've got the ratio of the two pieces of the side that was formed by the angle bisector, the ratio of the two pieces of the side that was formed by the angle bisector, and the ratio of those corresponding sides of the original triangle. Now, another way I could do it, and I could maybe this makes a little bit more sense, it's the same thing. I could take the ratio of the one side of the angle bisector, so say BD is to AB as DC is to AC. And that should be a consistent ratio there too. Because after all, these are equal, okay? And if I'm allowed to do interchanges on these, which are going to end up keeping the same consistent consistent ratio. So let's say that. I'm going to take number calculate, okay? And it might be easier. Look at BD to AC, okay? Take that ratio. We're going to set that aside, okay? So because that's kind of like the left and right side, if you will. And then I'm going to keep that consistent with the ratio, okay, of DC with the other side belonging to that which would be, of course, what is that? AC, okay, divided by AC, okay. And let's see. That's where I made my mistake here. So DC is the AC, okay, and I need to make that correction over here because this should be BD to AB. So I have to correct that. That should be AB, right? It shows the wrong value. Okay, so there we have it. Okay, so now we have a consistency. So here's triangle angle bisector theorem. Bisect one angle and it splits the opposite sides into a ratio where the two pieces of the opposite side are in a ratio consistent with the comparison of the two remaining sides of the triangle. Or you just look at this as, if you will, kind of a left and right side. Okay, so the left and right side would be BD is to AB, BD is to AB, as DC is to AC. And you can see that ratio is consistent either way. Okay, so either of those ratios will do it for you. Okay, I think it might be easier just to look at it as left and right, or you know, left piece of this triangle BD is to AB, and the right piece DC is to AC, and that is your triangle angle bisector theorem. Okay, and with those you should be able to complete the exercises that I will give you.